All right, let's look at this first problem. Okay, when you're dealing with the first one, we're looking at an index of 3. So right away, do we even need to consider absolute values here? No. You only need to consider it on even indexed radical, so it has to be an even number. So we can look to simplify. We're looking for perfect cube factors. So are there any perfect cubes that are factors of 16? You have 8 times 2. 8 is a perfect cube. It's when you simplify or pull this out of the radical, what is the cube root of 8? 2. And you have this factor of 2 left inside the radical. Make sure you keep your index the same as the original. Right, and then go to the next base, x. How many groups of 3 can we remove from the x's? 1. Comes out, how many x's would be left inside the radical? 0. Okay, move to the y's. How many groups of 3 can we remove from 5? 1, with how many y's left inside the radical? 2. Okay. Now again, we don't need to consider the absolute values because it's an odd indexed radical. So you don't even need to worry about it. Odd indexed radicals can be negative. Because if you take a negative number, multiply by itself an odd number of times, the product will be negative. Okay, if we move to the second example. Here we're looking at an index of 2. Keep in mind, this 3 that's written out front, is it the same size as these factor numbers written inside? Well, it's the same size as this 200, right? So 3 is a factor. It's not an index. And if it was an index, it would be written smaller. So just be careful with that. Make sure that you distinguish those. If you have any questions, make sure you ask whether something is the cube root or 3 times some value. Okay, but we're looking for perfect square factors of 200. Are there any? 100. So we get 100 times 2. So we have our factor of 3 that we started with. The square root of 100 comes out as 10. And this factor of 2 stays inside our radical. How many x's can we remove? We're looking for groups of 2. Out of 2 leaves 1 with no x's inside. How many y's can we remove? 1 group of 2 leaves 1 y, and then the z stays inside. Okay, so now as you're looking to completely simplify this, we'll multiply our 3 and 10. Okay, and let's test it. It was an even index, so we do need to consider the absolute values. Okay, in the original form, can x be a negative number? If we square it, does that guarantee a non-negative under the radical? Yeah, so x can be negative. It's not tied to anything else, so we can look at just the x alone. So in this simplified form, does x by itself being negative guarantee that this whole solution is positive? No. So what do you need around the x? Absolute values. Okay, let's test the y. If y is negative, is it even possible for y to be negative? If y is negative to an odd power means that this factor would be negative. What does that mean z would have to be? In order to keep the product inside positive, z would have to be negative as well. So y and z are tied together. Okay? Now, this doesn't mean they have to each be negative. What it means is they could either be both positive or both negative. If they're both positive, do we even need to consider the signs for absolute value? No. So that's why we're only testing if they're negative. So if y is negative, then that means z is also negative. And so when you look at this overall form, does this y that's out front, if that happened to be negative, is there a guarantee that this whole solution would be positive? The way it's written here? No. So what do you need around the y? Absolute values. What about inside? If y is negative and z also negative, is this guaranteed to be a positive inside here? Yeah, so you don't need any absolute values there. So your answer winds up being either what's written here, or you can combine that product xy, into one absolute value. Okay, the last example is the case of the second rule of simplifying, which is The first rule is met. The index is larger than the power. And however, there are common factors between those. So in order to simplify this, we cancel the common factors. So this index of 6 and this power of 3 have a shared factor of 3. 3 goes into 3 once, 3 goes into 6 twice. So we're looking at the square root of t. Do we need to check for absolute values on this? Was the original index an even number? Yeah, so we need to check for absolute values. And so if t was a negative cubed gives you a negative number. Can you take a negative number and put it inside a 6th root? No, so t can't even be negative, so we don't even need to test it. We know that t can't be negative, so we can leave it as it is. All right. I understand there will be some confusion on absolute values. Make sure as they come up in sample problems or practice problems, if you have questions about why, you ask. Because like I say, on the final, if this is the correct answer, guaranteed this will be one of the answer choices. And even though you might only be off by the absolute value symbols, on a Scantron multiple choice test, it still counts as if you didn't know anything about the problem. Okay, so be very careful when you're dealing with those. Okay, now, a question came up earlier about absolute values inside of radicals. Can that exist? I want to go through an example, and then we'll see if that example answers the question. Okay, simplify this. It's very similar to question C here. And you should be able to answer it pretty quickly using the same second step of simplifying. And can you figure out what the simplified form of this would be? Right, the index is higher than the power, but they do have a shared factor. So what do you do when the factors are shared? Cancel that common factor. So between 2 and 6, 2 goes into 2 once, 2 goes into 6 3 times. So your answer is cube root of x. And do we need to test for absolute values here? Was the original index an even number? Yes. So we need to test it, and let's see what happens. If x was a negative in the original, and then you square it, and then can you take the 6th root of that and guarantee to get a positive value? Yeah. So x can be a negative number. So if we look at what happens in this simplified form if x is negative, can you take the cube root of a negative number? Yes, you can take the cube root of it. But you know, since the original index was 6, an even number, this whole simplified form has to guarantee to be positive. Is the cube root of x guaranteed to be positive when x is a negative number? No. So what do you need around the x? Okay, so you would need an absolute value around the x, even if it's inside the radical, okay, for a problem that looks like this.